Hello guys, and in this lesson we're going to be learning about alcohols. Okay, so let's begin. So what are alcohols? These are compounds that contain the OH group as the functional group. So to determine them, we select the longest continuous chain. So let's start off with this one. So this chain is 1, 2, 3, so it's going to be propane. And then the carbon chain that contains the carbon which the OH group has joined gets the lowest number. So as you can see that the functional group is joined to only one carbon, so it's going to be position 1, and the format is always the alkane, position of OH and O. So as you can see for this one, this is a primary alcohol, is when this carbon joined to a functional group is joined to one other carbon. So we name this propan 1O. So this is 1, 2, 3 propane joined to the OH is joined to the first one, so it's 1, and O because it's an alcohol. Moving on to the second one, this is a secondary alcohol, which is when the carbon is joined to two other carbons and the functional group. So this is propan 2O, which you can see is joined to the second one, so 1, 2, or 1, 2 this way, and so it's 2, and there's an O because it's OH. Finally, this is a tertiary alcohol. It's when the carbon group joined to a functional group is connected to 3 other carbons. And because this is a methyl group, we name it 2-methyl-propan-2O. We always start with if the carbon chain is joined to another one, we always put this in. So if it's joined here, we do 3-methyl-propan-2O. Here's the same, but yeah, you get the idea. Okay. So oxidation. Oops, mistake. So oxidation of alcohols. So they need an oxidation agent, which is potassium dichromate. As you can see, K2Cr2O7. That's the formula you need to know. And we need to know reflux as well, because they're used for the oxidation for the alcohols. So reflux is heating with a condenser placed vertically in the flask to prevent loss of volatile substances from the mixture. It's just basically reheating the substance used. And for this one, we can see it's a primary alcohol. This one is a primary alcohol, which turns into an aldehyde. This is an aldehyde. The aldehyde is the functional group for this one, which contains carbon, double oxygen, and hydrogen. Yes, it's always like this. So it's propan now. This is Al. That's the functional group for this one. And to carboxylic acid, which is using 2 oxygens, so this is reflux, this reaction is reflux, using the reactions again, and it forms propanoic acid. This is the functional group. For any other ones, it's always oic acid, so it's carbon, double oxygen, and OH group. Moving on, the secondary alcohol, which forms into ketones, as you can see here, when this oxygen joins into this one, it's always going to be gnome. So at the end, it's always going to be gnome. So this one, as you can see, is propanone, and the functional group is C-double-O. And for tertiary, it does not get oxidized, so we see no reaction. Oh, I forgot to mention that all the reactions is always from the orange turns from orange to green. So these two will turn from orange to green, except from this one. So if the color doesn't change and remains orange, we can determine that the mixture we're using is tertiary alcohols. Okay, so that's the end of this lesson, and hope you like it, and like if you like this, and subscribe. Okay, thank you, bye.